Today I'm going to show you how to use Socat. In the previous video, I showed you how to install this for Windows and Linux, so you can head on over to GitHub and get this program. But it's basically, a multi-purpose relay, a socket cat, a netcat on steroids. So it's got a few different uses, but you can read all about it here. What we're going to do is kind of a TCP relay. We're going to basically output serial, and we're going to be able to connect to it by telnet. We can just type in an IP address and capture this, kind of stream this data over TCP. So I'm going to show you how this works. Let me pull up this camera that I've got right here. So I've just got a basic Arduino, and I'm just running a basic kind of sketch. So all it's doing is outputting temperature data to the serial port. And we can look at this by opening TerraTerm, a new connection. And I select serial and COM15. This will be important in a second, so you'll want to pay attention to this COM15. So if I open it, we're just getting temperature data. So, nothing special. But if we want to use Socat, we can use this command that I'm about to type. And you can see this, we've got, the command Socat, which we added to our environment variable, so we can just type it in anywhere. We're going to use TCP-listen, and we're going to specify a port. And this is actually COM15. So I kind of have a cheat sheet that you can look at right here. So basically, COM1 maps to TTYS0, COM2 maps to TTYS1, and so forth. So by the time you get to COM15, it will correspond to TTYS14. So that's kind of why, you see this here. So that's actually COM15 on Windows. On Linux, you'll see TTY ACM0 or something like that. But I'll show you that later. And then you're just specifying a baud rate, raw, and echo equals 0. So if I type this in, it's not going to do anything, but it is actually outputting data. And we can actually look at this by going over here. And I can just type in telnet 192. And this is the current IP address set on this machine, and just specify the port, and you can see that we're connecting to that data. So you can basically put this on a remote computer, and you can have it stream out data over TCP, and you can connect to your data remotely. So what I'll show you how to do is to connect to it using the Wi-Fi HaLow Bridge. So if you're not familiar with this, it combines LoRa and Wi-Fi, hence the name Wi-Fi HaLow. And it's got a long range and it's low power. So you can, shoot out your Wi-Fi signal over 2,600 feet, maybe further if you have line of sight. So, I bought this last year, and I've been testing it and doing a lot of things with it. So I'm going to make a few videos on it. And yeah, it's a really interesting technology that, I think it came out recently. So hasn't been out too long, but it's pretty useful for IoT stuff. And I'll show you how to do that. And if you want to follow along, I forgot to mention that this is kind of the schematic that I'm using. So I'm basically just using a TMP36. And it's wired to pin A0. So if you want to follow along. So here's the basic setup. You can see, it's just the Ethernet cable connected and power going to an outlet. So nothing complicated. When you first get these devices, you're going to have two of these modules. One's going to be marked TX, the other RX. You can see that at the top left. And this is the module that you want to plug into the back of your router. So they give you an Ethernet cable. They give you two Ethernet cables, so no need to buy your own. And you just plug it into the back and you're ready to go. Next, I'm going to have this set up. I'm using a Zimaboard. I'm using the RX module, and I'm just having two things connected to the Zimaboard. I got a Scamp 3 module and an Arduino connected to the USB. So I'm going to remotely connect to the Zimaboard. To recap, all I'm doing is simulating this on a smaller scale. So instead of 2,600 feet, I'm probably more about 10 feet away from the router. But you can put this out in a remote location and you can have your Wi-Fi extended pretty far. The transfer rate is not very fast, so that's why it's a perfect application for IoT stuff. So don't expect, high transfer rates using Wi-Fi HaLow. What I'm going to do now is I'm going to do a scan on my network for the Zimaboard. Right now I have it connected to the RX Wi-Fi HaLow bridge. So I'm just running it off of a power bank. So if you were to put this in a remote location, you could also run this in a remote kind of off-grid way. This network scanner is custom software that I wrote. And if you want to see a tutorial on how to create a multi-threaded network scanner, leave a comment, like, subscribe. I've got this in Visual Basic and C#. But if you want a free one, you can go to angryip.org. I'm not affiliated, but it's just a free version. The reason I did my own is because I needed a few custom things done. So if I do a scan on my network, you can see that I've got the Zimaboard. I've named it Zima Comp. So I've got a few custom functions that I wrote, such as I can backdoor, I can VNC desktop, which is what I'm going to do right now. So if I just type in this, I will be connected to the Zimaboard. I'm running Windows IoT on the Zimaboard. So now we are connected to the Zimaboard, or we're VNC'd into the Zimaboard. And from here, you can do anything. So there's a lot of applications, and we could be connected to this over 2,600 feet if we have line of sight. So you could be remotely connected in your home, and this could be out in a remote, maybe a barn or something, and you could just remotely connect to your Arduino or Scamp board. And if I just type in FF LEDs, you can see that I can just blink some LEDs. Type in 1 LEDs, you got 1 LED. And we can just do things like that. So we can remotely check in on things. I could have this Scamp 3 board be running things like I believe it has a temperature word. So we can get the temperature. And we can put this in a loop and get the temperature from the Scamp 3 board. It's onboard temperature sensor. And if I just disconnect from this and connect to the Arduino, which is on, I think, COM4, we can also pull the data from the Arduino. So we could get all this information remotely. We don't need Socat, but I'm going to show you how to use Socat anyways. So all I'm going to do is disconnect this. And what I'm going to do is open up a command prompt. And if I scroll up here, what I'm going to do is we're going to get the IP address, which I think we got earlier. To use Socat on the Zimaboard, I'm just going to retype in this command. So right now, Socat is running on the Zimaboard. I can come up to my home computer and I can type in the IP of the Zimaboard, which is this right here, and followed by the port. If I hit enter, I can be remotely connected to that Arduino that's streaming data over the Wi-Fi HaLow Bridge. I'm going to show you how you can also connect to the Scamp board. To connect to the Scamp 3 board, it's going to be a little bit more tricky. I'm going to run this command. This will be on the Zimaboard, and right here, I'm going to connect to the Zimaboard. And we see that it's, if you ever get this error, that means we have this not set correctly. So I can fix that by just typing S4. So we should be able to reconnect to this. And there we go. So we connect to the Scamp 3 board. I can type in words. You can see that it's echoed out, but it is going to run. So that's why this is a little bit more tricky. And in Windows Telnet, you can hit Command and the right bracket key, and you can enter in this prompt. Just type in, I think it's \help. And you can see that we have a few things that we can do. One of the things that we're going to do is use the send command. And I'm going to show you why this is kind of the tricky way to do it. And we should probably use Telnet on our home computer. So we can do send ffleds. And it sent the string to the Scamp 3 board. But if you look on the web camera, you can see it didn't turn on any LEDs. That's because we also have to send the line feed or the enter key also. So the way to do that is just to hit enter in this Microsoft Telnet prompt. Just hit the enter key, and you can see that it's typed in already. So all we have to do is hit the enter key, and you can see that it will light up the LEDs on the Scamp 3 board. So if you hate having things echoed out like this, it's kind of frustrating, but it does work. So that's why I'm going to show you how to connect to the Zimaboard running Socat using Teraterm. Now I've got Teraterm up and running on my home computer. So go to File, New Connection. The IP of the Zimaboard connected to the Wi-Fi HaLow Bridge is going to be this. We got this from the network scanner. So we're going to select Telnet and put in the port 54321. Click on OK. And we are remotely connected to the Scamp board. So right now you can't see. If I type in words, you can't really see anything come out until I hit the enter key. So to fix this, you're going to go to Setup, Terminal, and you're going to click Enable Local Echo. So now you should be able to see what you type. So if I type in words, it's going to output all the words that are on the Scamp 3 board. You can do the normal things that you would normally do. So you can get the temperature and so on. So this is kind of the better way to connect to your Scamp 3 board remotely. You could have Socat running. You can check in on things, and the best way to do this is to also set this as a service so that it's always running in the background. And in the event that your Zimaboard resets, you need a way to enumerate through the COM ports to select it. So I can show you how to do all that stuff, but this video is getting kind of long. So I think in the future videos, I'll show you how to set this up as a service that is always running. and how to enumerate through the COM ports so that you always select the board that you want. So it's kind of an advanced tutorial, but this will get you kind of going, and you can do a lot with this. So if you like this video, like, subscribe, and let me know what you think.